performance. But today, materials are no longer just inputs, they are mission enablers, if I can put it that way, because there are various types of materials that are used for lightweight properties, for stealth coatings, for other types of reaching further in terms of radar capabilities, gallium nitride, gallium arsenide as well. And they act as mission enablers, such as carbon fiber composites for reduction in aircraft weight, ceramic matrix composites for higher engine temperatures, and metamaterials, like I said, for radar absorption and stealth. So survivability, endurance, and stealth are increasingly material-driven outcomes, which is something very, very important we need to realize as industry. Now, coming to additive manufacturing defines how fast one can build, how flexibly one can design, and importantly, where one can produce. What I mean by where one can produce is that globally we are seeing companies establishing additive manufacturing capabilities in the forward areas. There are some changes happening in India as well. I'll build on them in my slides later on. But that is the future, wherein the soldier gets the system to manufacture it in the forward areas where they are present, so that they can iterate along with the industry can iterate it along with the end user, and new systems can be brought out at a faster pace, rather than something happening at the factory, which is in another corner of the country. So because production is no longer limited to factories, it can move closer to where the capability is actually needed, that is in the forward areas. If a part failed in the field, the supply chain used to take time, logistics used to take time, and that part can be now printed at the base or even in a forward area. But obviously, they have their own constraints, like certifications and all, which I'll come on to later. So this is fundamentally changing the response time that we are looking at. But the real transformation is not materials alone and not additive manufacturing alone. It is actually a convergence of both. Like Dr. Kamath also said in the morning, that there's no, it's not like additive manufacturing is better or traditional manufacturing was better. It's a combination of both, which will result into a hybrid manufacturing ecosystem that is the way forward. So earlier, design used to lead to material, which used to lead to manufacturing. Today, design plus material plus manufacturing, all three are getting integrated into the system. This enables complex geometries, reduced part counts, faster iteration, and lower costs. Now, just to move on, I would like to also give you a kind of a background on what is happening around the world. There's a lot of development happening around the world, and just don't go by the countries that I've mentioned. There are countries, even the ones that are not mentioned on the slide, are iterating very fast. Countries like Russia, countries like Ukraine, which are under a conflict at the moment, and additive manufacturing is giving solutions to a lot of problems. Talking about US Air Force, they are doing a lot of activities through additive manufacturing for the legacy fleet sustainment. Their B-52 bombers, then their C-17 Globemasters, some of the non-critical parts are being additively manufactured. The Navy is also using metal 3D printers on ships. The USS Essex, USS Somerset print critical parts within 24 to 36 hours. Field printing is also being taken up in a very, very fast pace. Companies like Firestorm Labs in the US have got containers which have 3D printers installed in them, and they print the modules of various types of UAVs. Whether it's an ISR drone or a loitering munition, you can print modules and you can use it as per the mission requirement. GE is doing a lot of work in 3D printed nozzles. China is also doing a lot of work in the 3D printed titanium structural parts for fighter jets. The PLA Navy is also doing a lot of work in that, in terms of manufacturing non-critical parts. Drone deployed manufacturing as well for additive manufacturing units. Israel is also doing a lot of work in terms of agility and combat adaptation. They use base level printing for tools, adapters, and mission-specific components. And they're also printing weapon suppressors and accessories. We've seen around the world, actually, a lot of companies have now started 3D printing pistols, small arms, some of the critical aspects of the small arms. So all these things are, in a way which needs to be done at scale. Coming to Europe, Europe has done a lot of work on the companies like Saab have 3D printed the external hatch for the Gripen aircraft. Naval Group has 3D printed a 200 kg propeller for their vessels. Thales is doing satellite components. There's a company in Germany called Helsing that's one of the first unicorns in Germany. They use 3D printing as well, but they also use something known as carbon fiber reinforced foam for their loitering munitions to reduce the weight and to produce those loitering munitions at scale. They're producing 6,000 to 8,000 LMs every month, and they're supplying to Ukraine and other NATO forces as well. And their factories are known as resilience factories. Obviously, the name comes for a reason. Then coming to, moving on to India. In India, we have a lot of things that are happening at a fast pace. Capabilities are developing. DRDO is doing a lot of work on additive manufacturing. Midhani is doing a lot of work in terms of developing various types of materials that are used in additive manufacturing. There is Zupa Aero Navigation, which is into autopilot systems for UAVs. That is already working along with a company called Divide by Zero, wherein they are setting up something what Firestorm Labs is doing in India. They are setting up containerized 3D printing machines in the forward areas, working with the EME Directorate and printing the drones. But all this is not required as a one-off. This is required to be done at mass and at scale. So there are these Indian Army workshops where all these things are happening. Agnikul Cosmos, which is a space startup, they have 3D printed a rocket engine, and they are doing a lot of work through additive manufacturing. DRDO, as I said, is doing a lot of work. Indomem has got metal additive manufacturing and binder jetting. They produce high-precision defense components. Even big companies like Tata, L&T, and other private sector players are using additive manufacturing for aerospace components. There are a couple of academic institutions as well, like IIT Indore. They have developed a metal additive manufacturing process. There are also new startups like Form Labs or RA3D, which is a startup that is printing their own, manufacturing their own 3D printers. But one of the biggest problems, which all of them say, as it's mentioned on the screen, that the ecosystem is not connected with each other, and everybody's working in silos, but things are improving, but that needs to be done at a faster pace. Also, there's a huge problem with certification. In the morning it was said that Semilac is doing some work on additive manufacturing components as well to certify them, because it's very important. Till a component is not certified, the end user cannot use it. It cannot be deployed in the field. So it's very important to look at certification. Skill gaps. Now, while we are all talking about additive manufacturing and to take the machines and place them along with the end user, but it is very important to educate the people who are actually using those machines. So that is where the companies that are also manufacturing these machines are also providing services to educate as to how to use the 3D printers to your advantage to produce various types of systems. Feedstock dependence, which is for a lot of years we've been talking about this, not just feedstock, even strategic materials we are importing. So there's no point in self-reliance if we depend on materials. The government needs to take in some policy aspects, maybe incentivize stockpiling of additive manufacturing feedstock, which is very much required. Because when there's a conflict and the supply chain gets affected, we won't be getting these materials that we require. So we need to develop indigenous capabilities. And obviously, the scale needs to be extended further. It cannot be as a one-off. It needs to be done at mass. So obviously, innovation exists, but deployment at scale doesn't, which we need to work on. So what is the solution? It's pretty simple. We need to connect the value chain. We need to integrate it from minerals to materials to manufacturing to systems. There's a lot of work happening. It started off with the rare earth manufacturing scheme, beach sand minerals. A lot of work is being done by Andhra Pradesh and other coastal states, wherein they are giving incentives to process these minerals to produce rare earth magnets, even recycling of magnets. Some companies are now starting to do recycling of magnets in India as well, which is a huge opportunity. Certification must become faster and adaptive. We need to have skills that focus on design-led capability, and we need to move from prototyping and R&D towards deployment. And finally, in additive manufacturing, feedstock is the capability, so we need to focus on that. So to conclude, I would just like to say that we often define Atmanirbharta as building systems in India, but true Atmanirbharta is deeper than that. It is control over materials, mastery of manufacturing, and the ability to sustain capability when it matters the most. That is when you are under pressure. Because during peacetime, everything is available. But when the chips are down, when we are under pressure, that is when the real test of self-reliance is. So because in future conflicts, the winner will not be the one who builds the best system, but the one who can build, repair, and replace it faster than anyone else. Thank you. Jai Hind.
Thank you, Balpreet, for very lucidly bringing out the industry perspective on advanced materials and additives. I'm sure the audience will have some questions. I'll request the audience to ensure that the questions are saved somewhere so that at the end of the session, we take them on. I would like to now invite Wing Commander J.K. Shahu to give us an insight into life cycle support and indigenization.
Good morning, ladies and gentlemen. I am Wing Commander Sahu, and in the next 10 minutes, I'll be discussing about life cycle support and indigenization. During my presentation, I'll be covering a perspective towards life cycle support, modernizing life cycle support, economics of its sustenance, role of indigenization and its efforts, challenges of modern warfare. And before I conclude, I would also discuss about open, sustainable approaches. A life cycle support is basically the efforts to sustain operations of platform or any equipment throughout its service life. Right from the induction till the time the equipment reaches to its end of life, maybe a museum. The entire journey is life cycle support. Well, we have some traditional ways and means to support the entire life cycle of any equipment. In the initial phase, probably a warranty cover is provided by the OEM. Later on, for a few years, we may expect annual maintenance contract or comprehensive maintenance contract like tools to support it. Sometimes with long-term rate repairs or maintenance agreements. And at midlife, we also do some upgrades. If the transfer of maintenance technology is part of the contract, then in most of the cases, we transfer the technology for eye-level maintenance setup at the field unit